Okay. Okay. So on Tuesday, you watched a video. You watched two videos talking about inverse functions. Inverse functions are one of those skills that we start working with a little bit more in Algebra 2 um, that we see in pre-calc, and we even do see uses of it in calculus. Um, uh, so there are three objectives that we're going to be tackling between today and tomorrow. One, we're going to determine a domain over which the inverse function of a specified function is defined. Okay. Two, we're going to construct a representation of the inverse given a function that is invertible on its domain. And three, we're going to verify that one function is an inverse of another function using a composition. Okay. So this is even, borrowing some of that material from that very first lesson. Okay. If we don't get to that tomorrow, we'll get to it on Monday. Okay. So, so to borrow some of that language from earlier, uh, defining what a function is very important. Okay. We said it was a pattern where one element of the domain or the input is assigned to one element of the output or the range. So then the inverse, this is really important. The inverse is a pattern where one element of the output of the function f, okay, so we're defining the inverse of the function f using the function itself, okay? So it's a pattern where one element of the output of the function is assigned to one element of the input, okay? Um, the whole idea of an inverse is actually really, I know this might sound a little confusing, is actually really easy, okay? Because what an inverse is that you're taking all the x's and they become the y's, right? You take all the y's and they become the x's. That is an inverse. Whether you're looking at a table, a graph, or even a function, okay? So now let's talk about some of the notation that you saw in the homework that you've begun, and you're going to see throughout this lesson and even like moving forward, like beyond this class. So we know that function notation looks like this, right? We do f of x. And this typically will equal a particular value, right? We plug the x in and we get something out, right? So this is the input. This is the output. Now, there's also function notation with an inverse. The inverse of a function is defined by f with a little -1 as an exponent. Except it's not an exponent. It's just something to mark this function off as the inverse of f. Now, when I think about if I plugged in a value, I got out a value, what the inverse tells me is that the opposite is true. Okay, maybe the opposite is not the right idea. But basically, what it's saying is that the output of the function becomes the input of the inverse. Okay, and this is why we talked about inverse operations first. When we did inverse operations, when we think about like the square root and x squared, When I plug in 2 into x squared, I get 4. But then when I do the inverse operation of x squared, it's the square root, right? When I square root that 4, I go back to the 2. Okay? So that is what this function notation is telling us, is that when I plug something into the function, I get the output. If that output becomes the input of the inverse, I get back to where I'm started. Okay? So it's a little dance that these numbers do. Okay. So that means, for instance, if a problem asked you to find the inverse of g, let's say of 3, that is some number. I can rewrite this as that. Because what it's saying is that, okay, I'm trying to find the inverse of g at 3. So that means 3 is the output of the non-inverse. There's like the inverse of the inverse is like the function you start with. So when you see like the inverse of g of some value, you can always rewrite it like this. Okay. I know this comes up on the homework. Okay. Now, one of those words that is going to come up in this lesson and in other contexts as well is the word invertible. Well, hold on. I'll just stop here. Are there any questions about the notation? I feel like the notation is pretty straightforward. And this can take you a lot of places. When you understand that you can rewrite things like this. Okay. So our first kind of after talking about the inverse, one of our first terms is the word invertible. Invertible means that the inverse of a function is actually a function. Okay? Because that's not always the case, as we're going to see. So when we create an invertible function, we have to do at times something called restricting the domain. Restricting the domain means we are going to create a domain so that the inverse is actually a function. Okay? So let's take x squared as an example. Okay, this isn't right, so put that in. So this is x squared. Okay. I'll say this is f(x). All right. So what I'm going to do is I'm going to find the inverse of this graph. So as you saw in the video, as we've kind of spoke about at the beginning today, the inverse is when you flip the x's and the y's. So for instance, -2, 4, that's going to become 4, -2. And I'm going to put that in a different color. Well, here, let me label all these points so that we can just change colors once. This is -1, 5, 6, 0, 0, y1, 2, 4. Right? But now, this is going to, now I'm going to graph the inverse. So -2, 4 becomes 4, -2. -1, 1 becomes 1, -1. 0, 0 stays the same. 1, 1 stays the same. And then 2, 4 becomes 4, 2. So this is the inverse of x squared. We should notice that the inverse is not a function. That's because if I go back, I'm going to zoom out. Because if I go back to my definition, a function is a pattern where one element of the input is assigned to one element of the output. We see that that's not true here because at every point from 0 on, there are two answers, right? When we go to 1, it could be 1 or negative 1. At 4, it could be 2 or negative 2. This is where we introduce restricting the domain. So, when we restrict the domain, we are cutting off some of those domain values. Now, what did we say that the inverse operation of squaring something is? What's the inverse operation of squaring something? Square rooting it. Now, when we think about that square root graph, without any of those transformations, is it the top half or the bottom half? If we graphed it on the calculator, the top half. It would be the top half. It'd be the top half. I'm not gonna draw it in just because I don't want you to have to feel like you have to do another one or do it like a different type of line. Now let's think about the top half of this function. Is the top half of this function corresponding to the left side of the red graph or the right side of the red graph? Does the top half refer to the left side or to the right side? The right side. Good. So this is what we call restricting the domain. If I take the inverse of f of x, which is x squared, I would restrict the domain to only the non-negative values. I'll write it two ways.